All right, so in algebra, you see these two things all the time, radicals and exponents. Now, they might look like they're from two completely different mathematical languages, but they're really just two ways of saying the exact same thing. In this explainer, we're going to learn how to translate between them. Let's dive in.
So, take a look at this. On the left, we have a radical. On the right, a base with a fractional exponent. They look totally different, right? But here's the thing. They are mathematically identical. So, how can these two things mean the exact same thing? By the end of this, you'll not only get it, but you'll be able to switch between them like a pro. And that is a super handy tool for simplifying expressions.
So how do we crack this code? How do we do the translation? Well, it all boils down to one simple but super powerful rule. Let's open up the rule book. Okay, this is it. This is the Rosetta Stone that connects the two worlds. A raised to the m over n power is just a fancy way of saying the nth root of a to the m power. This formula is our master key. Now let's really break down what that fraction on top is telling us. Let's see this rule in action with our original example. See that exponent 2 over 5? The top number, the numerator, 2, that becomes the power on the 8. And the bottom number, the denominator, 5, that becomes the root, or the index, of the radical. It's that direct. Here is the easiest way to remember this, and trust me, you'll want to remember this. The numerator is the power, the denominator is the root. A great way to think of it is a flower. The flower of the power is on top, and the roots are on the bottom. So it's always power over root. If you can lock that phrase in your head, you'll never get this wrong. Hey, just a quick vocab refresh while we're at it. That little number tucked into the checkmark part of the radical symbol, that's the index. That's the root we're talking about in our power over root mantra. And the number inside, well, that's called the radicand. Easy enough, right?
All right, enough with the theory. The best way to really get this stuff is to actually do it. So let's jump in and put this rule to work with a couple of examples.
Let's start with a really common one you'll see all the time, the square root of x. Now you might be looking at that and thinking, wait a minute, where's the power and where's the root? Well, they're actually hiding in plain sight. So here's the deal. Anytime you see a variable just sitting there, like x, it has an invisible power of 1. And anytime you see that classic square root symbol, it has an invisible index or root of 2. So what does our rule say? Power over root. That gives us x to the 1 over 2. See? Simple? Okay, that was a good warm-up. Let's tackle one with all the numbers right there in the open. We're going to rewrite the fourth root of y to the third power, and we're going to use our trusty power over root rule, step by step. Okay, let's break it down. First, what's our root? It's the index, right? So that's the 4. That's going to be our denominator, the bottom of the fraction. Step 2, what's the power? Well, that's the exponent on the y, which is 3. That's our numerator, the top of the fraction. So, put it together, power over root, we get y to the 3 over 4 power. Done. Okay, now I have to show you the #1 mistake people make when they're first learning this. It's a really easy mix-up, but if you know to look out for it, you can avoid it every single time. I'm going to say it again, because it is that important. The power is the numerator. The root is the denominator. Power over root. Whatever you do, do not flip that fraction. So look here. The correct way to write the fourth root of y cubed is y to the 3 over 4. But if you accidentally flip it, you get y to the 4 over 3. And that's not the same thing at all. That would mean the cubed root of y to the 4th power, a completely different expression. So always, always, always double check, is the power on top? All right, you've seen the rule, we've walked through examples, and we've even looked at the biggest pitfall. Now it's your turn to put it all together. Time to decode one yourself. Okay, here's your challenge. I want you to write the square root of z to the 5th power using a rational exponent. Go ahead and pause the explainer right here, grab a piece of paper, and give it a shot. All right, you ready? The answer is z to the 5 over 2. How'd you do? The power is 5, so that's our numerator, and remember, it's a square root, so the unwritten root is 2. That's our denominator. Power over root, 5 over 2. Awesome job. So if there is just one thing you walk away with today, let it be this. A fraction and an exponent isn't just some random number. It is literally a set of instructions. The numerator tells you the power. The denominator tells you the root. That's it. That's the whole game right there. So you might be thinking, okay, cool, I can translate between these two forms, but why does it matter? Well, think about this. Now that you can turn a clunky-looking radical into an exponent, you can use all those exponent rules you've already mastered to simplify really complex problems. And that is where this skill becomes a true superpower in algebra. Thanks for joining me.